Hey students, we're going to look at graphing tangent functions today, but I really want to explain to you why they look the way they do, so it'll make some sense to you. But I'm going to have to take you back to cosine and sine values to explain that adequately. So let me show you what I mean. If this is theta right here, and we are talking about the cosine of theta, which is the adjacent over the hypotenuse. The hypotenuse is the biggest side. So no matter what you use for the adjacent, if your hypotenuse, let's say it's 1, this adjacent side is going to be smaller. So there's no way for that ratio to hit 1. The sine is the same principle. If it's an opposite over hypotenuse, and the hypotenuse is the biggest side, you're always going to have some value less than 1, but not so on your tangent. Since your tangent, here's theta, is opposite over adjacent, there, which is the slope, by the way, it's your y over your x. This could be any value, right? It can be bigger than 1. This might be a 5, and this be a 1. This might be a 12. This is a 1. This might be 50. This might be 1. It's unlimited. Also, let's look at this. If we are talking, and I've made a chart here. Well, I stole the chart. Okay, if we were talking about the slope, which is what the tangent is, like here it's 0, and here it's 1, and here it's more than 1. Look at this. It gets more and more and more and more and more and more steep. There is no limit to how steep it can get. So look at these values right here. These are actual tangent functions. If you use 0, it's 0. At pi over 6, the slope is 0.58, a little bit more than half. At pi over 3, now look, this is pi over 3, right? The slope is 1.73. At 1.5, it gets even bigger and larger and larger. I mean, look at that slope, how big that is. So it can get pretty doggone big. You see my point? So let's get started. Let's graph y is equal to tangent of theta. Now to do this, you begin by finding the period, just like you did before with cosine and sine, only this time you're going to use pi over b, and I'll show you why. Because a tangent is going to repeat itself every single pi. You know, here's a tangent, and then it just repeats itself. So I need you to just use pi over b to find your tangent. So in this case, and remember your b is a coefficient, so it's pi over 1. So in this case, it's pi. Okay, so I know that the period is pi. Now to determine the asymptotes, which are pi over 2b plus pi over nb, let me explain. Okay, since I know that it's undefined here, I'm looking for those undefined places. And it's every pi over 2, which is where you're getting this pi over 2 divided by the b, because you know you're finding the period there. So it's for every period it's pi over 2, and then every pi after that. So in other words, n being 0 when it is 0, when it's 1, when it's 2, when it's 3, when it's 4. Okay, so for every period after that, it's here, and then here, and then here, and here. So that's where I'm getting this formula, if you will. So since the b was 1, in this case, it's pi over 2. See, it's pi over 2 times that 1, the b was 1, plus pi over n. Now I'm going to graph this for you. It makes more sense when you see it graphed. Okay, so at pi over 2, I'm going to have an asymptote. And then every pi after that, so pi over 2 plus 0 pi is right there. And then if I add pi to this, and see I've graphed off every half pi, it's here. And then another pi, there's a half a pi, a whole pi. So what happens on the tangent is that you kind of need to go on the other side as well a little bit. So if this was a nice graph, these would be equally spaced apart, but I didn't use graph paper. Let's do step 3. Okay, now you're going to make these coordinates that are centered between the asymptotes. Use a midline. Now here the midline is 0, right? And that is because at 0, I'm going to use another color, at 0, the tangent is 0. And then at pi, it's 0 again. At 2 pi, it's 0 again. You want me to show you unit circle to prove? See, it's 0. It's 0. It's 0. See, you're going halfway in between. These are my asymptotes, right? This represents my asymptotes. I'm going halfway in between every single time. Isn't this kind of easy? Okay, and then now because this is tangent and not cotangent, they are going to be increasing. In other words, at 0, it increases and just goes up toward the asymptote. And on the bottom, it before 0, right here, it's negative, it's negative, it's negative, it's negative, it's negative. It hits 0, then it's positive. And this is what I'm actually drawing. And so all I had to do really is, once I find that midline, is I am simply hugging, for lack of a better word, the asymptotes, just like that. And you can imagine if the midline were changed, like it was a 4, then let me go ahead and kind of draw that. It'd look like this. So it would still have the same shape. And they call the amplitude undefined. Because look, it is undefined. There's no way to say how high this thing is going to go. Case in point. Okay, dear ones, so that's all you have to do in order to do the tangent. So make sure you write down steps 1, 2, and 3. We'll walk through that together a few times tomorrow. And now let's look at cotangents. Very, very much like it. Step 1, begin by finding the period. So let me create an equation. Let's say y is equal to cotangent of x. We'll do the parent function. Okay, so here, as you can see, the period is pi over b, so it's pi. Step 1 is done. Step 2. Now the cosine sine, which is your cotangents, are undefined at pi times n, barring any phase shifts. So in other words, look, if you have cosine over sine, it's undefined here, and here, and here. So that's 0n, 1n, 2n, 3n, 4n. Oh, I just said that wrong. 0 pi, 1 pi, 2 pi, 3 pi, 4 pi, hence the pi times n. So let's go ahead and create our asymptotes. Okay, I'm going to do those in yellow. There's one. On cotangents, that's one of the telltale signs you can tell that you're working with the cotangent, is that one of the asymptotes is on the 0, whereas it's not on the 0 on the tangent. So I've done that. Now I'm going to find my midline. So step 3 is to find your midline and place a coordinate or a point on each midline. Okay, so I wrote that for you, and the midline here is a plus 0. So I'm gonna, and here's what's so nice. There's so much symmetry. Place a point on the midline which is halfway between the asymptotes. So it's 0. I wish that was had better symmetry. If I had drawn it to scale, it would, I promise. Okay, and now the step 4 is that here on the sine and the cosine, because it's cosine over sine, it actually goes backwards. You know how this gets more and more and more positive? The cotangent, this is a tangent, the cotangent gets more and more and more negative. So it's going to look like that. So let's do our cotangent graphs. They go in the opposite direction. This time, it looks like that. And you just keep on doing that. They're kind of fun. Well, depending on what your idea of fun is. So, and there we go. I have created a cotangent graph. And that's what they look like. They're periodic. They keep repeating the same thing. So hopefully you've written these notes, step 1, 2, and 3 for the cotangents and tangents. Draw your examples of the parent functions, and as always, take care.